Number 8, we're going to do something completely different. In the beginning of the notes, I talked about that you could reflect over a line, and I said there's usually two that we do, besides the x and the y-axis, y equals x and y equals opposite x. They're going to pick something completely different. They're going to pick x equals 2. So we're going to start out by graphing something. We're going to graph the equation y equals x plus 1 squared. What happened to my x squared graph? Which way did it move? Left 1 is correct. So I can take my x squared graph, move it to the left 1, so it looks like this. Aha, I didn't use that. So my vertex is at -1, 0. And if I want to plot some points, just to be sure, I could pick x and y, or x and f of x. And maybe I pick points like, since I know -1 is in the center, and that would produce a 0, maybe I pick points like -2 and -3 to see what happens, and 0 and 1. So if I'm using a table, that's what I could do. So I plug in a -3 in for the x. -3 plus 1 is -2. -2 squared is 4. So at -3, I'm at 4. Holy crap, dude. Sound like you're dying over there. -2 plus 1 is -1 squared. It's +1. And then if I put in a 0, out pops a 1. And if I put in a 1, out pops a 4, because it's symmetric. So that's kind of one of the cool things, that you can kind of see that as you start plotting points. And what you'll notice is they want us to reflect it over the line x equals 2. So now let's look at the new line based on that. I'm going to do that in dark blue. But first I probably should draw that reflection line. So I'm going to do that reflection line in a bright color so you can kind of see it. Hopefully, well, at least hopefully you can see it. Here's x equals 2. And I'm going to reflect it over that line in dark blue. So let's see what happens. The point that's 1 unit away now is 1 unit on the other side of that line, because that's the mirror. The second point that I'm going to reflect is 1, 2, 3, 4, 5 units away. So I'm going to go 1, 2, 3, 4, 5 units away. And then the vertex is 3 units away, so now I go 3 units away. And likewise, with the other points, and then I just redraw my parabola. And you can see how it's been reflected over that green vertical x equals 2 line. Kind of weird. Same idea. You can reflect pretty much over any line. Okay, so now on this slide, they're doing a whole bunch of things and they just want to know what happened. So let's take a look at a few things. First of all, what does the negative on the outside do? Flips over the x-axis. So reflected over x-axis. What did the -2 on the inside do? Excellent, right 2. And then last, I have this +6 on the outside, which means I went up 6. So whatever the original graph was, I don't even know what it was, but I flipped it over the x-axis, and then I moved it to the right 2, and then I went up 6. I don't even know what the original graph was. In number 10, it says, graph the following with your calculator. Write the equation of this graph that would be reflected over the y-axis, and then test the new one. So I'm not so worried about that. What you need to know, in my opinion, based on what they're trying to show here, is that if I try to rewrite this equation reflected over the y-axis, then the stuff that's on the inside, when they say what, that's really making me mad. Let's try that again. So if I look at reflecting over the y-axis, that tells me when I reflect over the y-axis, this thing on the inside gets changed. So my new function would be y equals, parentheses, the opposite of x minus 3 squared minus 6. And you can graph this on your calculator later if you want to see both of the functions, the original and the new one. I'm not really too worried about that. I'm pretty sure you can type stuff in your calculator. So if you want, type this green highlighted one in your calculator, then type the purple one in your calculator, and you can see it's been flipped over the y-axis. So the big question in number 11 is, why doesn't this parabola thing, this square root thing, why does it look like half a parabola? Why isn't the other half of the parabola showing up? That's the big question. So as you look at the parabola, there's not really a trick, if you will, but the one that they show us here in the orange says that I'd move to the right 4 units. So 1, 2, 3, 4. It kind of looks like, as a basic sketch, it looks something like this. And what they're asking is, where is this part down here? Why isn't it showing up? And the reason it's not showing up is because there's stuff underneath that's not showing up. See ya. Kind of the big idea is that the stuff down below here, you would have to graph with y equals the opposite of the square root of x minus 4. And that's because you'd be reflecting it over, of course, the x-axis. And so you see that that negative symbol here in the front is showing you that you've reflected over the x-axis. And since you only have the positive square root and not also the negative square root, that's why you're only seeing the top half, because it hasn't been reflected over that x-axis. Down below in numbers 12a and b, what they want you to do is to graph the reflections. And so in the very first one, what you'll notice is that they're talking about graphing the reflection where you have the negative sign in front of the f of x, which means that you're reflecting it over the x-axis. So if I reflected over the x-axis, it would look something like the following. So if I graphed it, now I have the pink function. And they're not even really telling you what the algebraic equation is or anything. They just want to see if you can reflect it over that axis. And in the second one, since the opposite sign is on the inside of the parentheses, we talked about how that means it's a reflection over the y-axis. So now I just take these points and reflect them over the y-axis. And as I do that, I see my new graph as well. Sorry, I'm counting. 1, 2, 3, 4, 5. So our new graph looks like this. And that's because of which axes I had to reflect over. So in the first one, of course, it was the x-axis that I reflected over right here. And in the second one, it was the y-axis that I reflected over right here.